And thank you very much, Mr. Yasir Nawab from the National Textile University in Faisalabad. I think we met also before, and I'm happy that you talk about fly ash reinforcement composites, fabrication properties and application, because in Pakistan, still many boiler houses are run by coal. They're coal-fired boilers, and so we have a lot of fly ash there, and he will tell us what to do. Before doing so, I just give the information that you have done your bachelor degree at the National Textile University in Faisalabad, and then you went to do your master's to France. So you speak French as well. And you also did your PhD at the University of Nantes. Congratulations to that. And now you are an associate professor at the National Textile University in Faisalabad in Pakistan. And you're also the team leader of the group Textile Composite Materials. And we are very happy to have you here and are excited now to hear from you about the fly ash. Yes, here,
thank you,
of course,
Professor. Thank you very much, Professor. So, along with me, in order to prepare this presentation, Dr. Kashyap, Assistant Professor, Department of Materials, he helped me. So I would like to acknowledge his contribution. So National Textile University is in Faisalabad. It's in the eastern Pakistan. We are there since 1959, and we do research and provide bachelor, master's, and PhD education, focusing on the complete value chain of textiles. So I'm leading National Center for Composite Materials as well as School of Engineering and Technology as Dean. So the contents of this presentation mainly it's in two parts. The first part is about fly ash, its brief introduction, collection method, global production, its classification, compositions, costing, then sector-wise utilization, applications, and then I will be talking about use of fly ash in reinforced composites, and then potential for its use in fiber reinforced composite materials. So fly ash, in fact, is a particulate waste of coal in core burning plants. The particle size in the fly ash is about 20 to 150 micrometer. So generally, we captured the fly ash from the flue gases using electrostatic precipitators or filter fabric collectors. The composition, in fact, it depends upon the source and composition of coal. The major contents include silicon dioxide, aluminum oxide, calcium oxide, etc. So mainly, if we are talking about coal power plants, so the collection of you can say the ash is at 2 points. The first point is the bottom ash at the point of burning, and then the fly ash. In fact, it's from the filters. We collect it regularly. You can say after 8 hours each. So in textiles, the major source are the boilers. In Pakistan, we have a lot of boilers. You can say the number is about 6,000 to between 6,000 to 8,000 boilers, and most of them they use coal or the rags. And then the second source is brick kilns. So when we use coal at the point of flame, again we have a bottom mesh. It's about 30 to 40%, and then collection in the precipitators or the filter is about 60 to 70%. So if we are collecting it, of course we can use it, but unfortunately, in most of the boiler houses in Pakistan, it goes to air. and the same is for the brick lanes. Now there is regulation. The government is trying to, in fact, regulate and control this that lease in the air, but unfortunately, the most of it goes to the air. So if we classify the fly ash, there are two types, two classes, class C and class F. So class C is that which contains more than 20% limes. So it can be used easily in the civil applications as it's self-cementing. And class F, mainly it contains less than 7% of lime. So it's not self-cementing, you have to add additives. So fly ash, in fact, it's not. It's very cheaper. Its cost is about $5 to $10 per kg, or sometimes it even presents a negative cost. It means if someone is working on the disposal, so for the disposal you have to pay to him. In Pakistan, it's much cheaper as compared to the world. A 50 kg bag price is about 300 rupees per kg. You can say about $2 is the cost of 50 kg bag. So fly ash, in fact, it's available. It's a very cheaper price than soil. So mainly for the land filling during construction, uh, the people they are using it. So, in general, in polymers, in composites, we use the particles as fillers. The objective is to make the material stiff and to give it some mechanical stiffness and other improve its other properties. So, in general, what we are using is silicon carbide, alumina, and other fillers like this. So, fly ash, if we compare the cost, is in fact much cheaper as compared to others. So globally, for example, if we look at India, so they are producing about more than 200 million ton per year of fly ash, and they are only using 40% of it. China is producing a lot, and but their in fact utilization is about 60%. If we talk about Europe, the production is lesser, and the whatsoever it is being utilized. If we talk about Pakistan and even about Bangladesh, I could not find any data, especially for Pakistan. I know there is no consolidated data that how much the fly ash is being produced and how much is utilized. Mainly, the utilization is to fill the land because there is a lot of real estate is going on. So the user, he or she, they pick the fly ash and use to fill the land. So global fly ash market, in fact, in 2019, it's about 8.54 billion US dollar, and it's expected that in 2027 it will be about 13.33 billion US dollar. So most of the fly ash that we are using globally, 44% or roughly 45% is used in cements and in concretes. So if we talk about Asia Pacific, $4.15 billion market was the market size in 29, which is increasing. So fly ash, it has several applications. For example, in civil, which is the major application today, then the ceramics, thermal insulations, pollution controller for the filtration, and gypsum boards, and aerospace and automotive industry as composite materials. So, in fact, these are the potential applications that we are exploring at our National Center for Composite Materials. And we are very confident that this fly ash can replace many fillers that are being used today. So one of the application is the fly ash bricks. So there are two possibilities for fly ash cement bricks, in which we use 8 to 10% of cement along with fly ash and sand. And the second one is fly ash, lime and gypsum bricks, where we used 10 to 20% of lime. In fact, the process of making the plant that we use, it's a simple plant. We need a pan mixing where we mix all the constituents. Then it's conveyed to the brick mold, and after the pressing it, then there is curing. In general, the curing, it takes 20 to 21 days. So the cost of fly ash bricks, uh, today, if we talk about Pakistan, is lesser as compared to the clay or red bricks. It's 4 to 5 rupees, Pak rupees per brick. You can say it's 2 to 3 cents. Fly ash brick, and the red clay brick is about 6 to 7 cents per brick. So if we compare the mechanical properties, the density of fly ash bricks is lesser. They are lighter in weight as compared to the conventional red bricks that we used mainly in this part of the world, in Pakistan, India, Bangladesh. So fly ash bricks, they are lighter in weight. Their compressive strength is good as compared to conventional bricks. Their dimensional tolerance is higher. When we in fact transit or transport 5 to 7% of the bricks, they break, and there is wastage. The wastage in case of fly ash bricks is lower, and their shape can be maintained very easily as compared to normal clay red bricks. So polymer reinforced composites, in general, polymer reinforced composites, they are made using two types of reinforcement. The first one is uh, like reinforcement in the form of particles, flakes, fibers, or fabrics. So 90% of the composites, they are made with the matrix, which are polymers. A little percentage is also made with ceramics and metals as well. So composites, they are preferred because you can design the customized solution with respect to properties, with respect to cost. You can customize them. So based on reinforcement, there are three types of composite: particle reinforced composite, fiber reinforced composites, and then structural composites using laminates, using sandwich panels. So most of the composites that we produced are with the fiber reinforced polymer composites, and then we add some particulate reinforcement in order to like adjust its properties, as I have mentioned earlier, to give it some stiffness and other things. So what we are trying to do these days is that we are hybridizing the both type of composite, fiber reinforced composites with particle, or you can say the other nano reinforcement or micro reinforcement, in order to get the desired properties. Based on matrix, there are three types: polymer matrix composites, metal matrix composites, and ceramic matrix composite. As I have mentioned earlier, that polymer matrix composites, they are about 90% of the volume of composites. Metal matrix composites and ceramic matrix composites, mainly they are for high thermal ranges, and for the application where in fact friction and abrasion is high. So in daily life, the mostly used composites are polymer matrix composites. So I will be sharing, in fact, two examples of polymer reinforced composites made using fly ash. The first one, before that, I will be sharing about the process of making composites with fly ash. For example, we will be in need of fly ash particles, matrix. It can be any polymeric resin. The most challenging point in making these composite is the mixing of the uniform mixing of fly ash particles into the matrix. So for that, we use stirrers like magnetic stirrers and magnetic or high speed mechanical stirrers, and sometimes we use sonication bath as well in order to assure the dispersion which is uniform. In order to make composite, we are in need of a mold as per desired shape. So we mix it, we do sonication, then we pour the mixture in the mold in order to get the final shape. And then we make a composite, and if we are like working in a lab, we cut it in order to test it as well. So first example that I'm going to share with you is high density polyethylene polymer mixed with fly ash. It's a thermoplastic polymer. So the fly ash, it was taken and then it was mixed. It was mixed in acetone so that the dispersion can be made. And on the particle, there was in fact a coating of fly ash, the coating of fly ash on the particles of high density polyethylene. Then these particles coated with the fly ash, they were fed into the hopper, twin screw extruder, and then we get the films which were ultimately converted into the composites. So using this method, the dispersion, it was very good. There is another example, it's with epoxy, a thermosetting resin, the fly ash. In fact, it was used along with it at various percentages. In fact, when we are working with the matrix, another problem is matrix like thermosetting matrix. There is a problem that when we add it into the matrix, the viscosity of matrix it increase. For example, if we increase the percentage in volume percentage of fly ash that we are using in the matrix, so there is an increase in viscosity. This increase in viscosity can be controlled for a specific time by increasing the temperature. So this one, in fact, it was done for three temperatures: 20 degree, 40 degree, and 60 degree centigrade. So at 60 degree centigrade, the effect of this in viscosity for a limited time, you can say for 1 hour. This is a sufficient window in which we can control, we can do our manufacturing. Another problem, in fact, the density of polymer, it ranges between zero point 0.9 to 1.2 gram per centimeter cube. The density of fly ash, in fact, is lesser. They are very light particle. When we try to mix them, there is problem of wettability. And in general, for composites, and then aggregation of particles as well. So in order to improve that, in composites we do surface treatments of particles. So there are some surface treatments of particles which are being reported. uh, Untreated, if we do, I have added only one example for compressive strength. So if we do different surface treatments like cleaning with acetone, then treatment with paraffin oil, then do the silane coupling treatment. So only with the cleaning of surface, we get the good like wettability, and the proof of that is that the compressive strength is increased significantly. So it means by proper dispersion, by proper cleaning of fly ash, we can add these particles to the composites, whether they are thermosets or whether they are thermoplastics. So when we add to it, the tensile stress and strain curve is given here. So when we add particles to the when we add fly ash particles to the polymer, so in fact their modulus increases. There is no significant increase in tensile strength. The compressive increases, the bending stiffness increases, the impact strength increases, but the impact on the tensile properties is not very significant. However, if we talk in terms of strength, however, the modulus, in fact, it increases significantly when we add particles in it. However, if we change the particle size, of course, for that we will need a further classification. But if we use particles with lesser size due to their higher surface area, the tensile strength increases as well for different percentages of fly ash. So the applications of fly ash composites, the potential applications can be in automotive body parts, aerospace and aircraft structural parts, defense applications, fireproofing of civil structures, thermal insulations, packaging, sports equipment, etc. I have not shared, in fact, the examples with fiber reinforced composites. I only discuss the addition of these fly ash particles to the polymers. So, the conclusion: fly ash is an environmental hazard which need first we need to like collect it, and if it is collected, then the next step will be to convert it into some eco-friendly products. This waste, it can be easily recycled into various valuable products. What we are working on is to convert these fly ash particles to use them into the composites in various ranges, like for low tech, for medium tech, and for even high tech composites parts. So these are lightweight, uh, they are cheaper, they are fire and heat resistant, and these composites which are being made from the fly ash particles, they have potential to being used in construction, automotive, insulation, and pollution control industry. Thank you very much.
Been